show a way that you can sometimes run Vivado or run Verilog without having Vivado. So I'm showing that. So you can do this if you want to get an account, or just go ahead and get Vivado open so that you have that. So I am going to just talk a little bit while I'm waiting for everyone to be ready. So this is a website that you can use to test your Verilog code if you can't get into the lab or if you don't have Vivado running on your computer. So if you go to the website edaplayground.com, it probably will open up to a screen that looks like this, and you would want to go over to this top right, and well, I'm logged in, so I'm going to log out. And then you'd go to this top right where it says log in, and you would want to create an account to get full access to EDA Playground. If you don't create an account, you can't run the stuff, so that won't help you. So you'll go to register for a full account. You need to put in your LSU email address because it won't give you an account with a Gmail address. And all you need is a password. Put in LSU for your company name, your name and student, and then that you agree. And then you can get an account on this website, and it allows you to test various different kinds of software. And honestly, I don't know much about it. So I don't know if it's very good or not. I just found it, and I found that it does work for Verilog, so I have used it. And let me get the chat open. Participants. And I don't know your name, so I can't ask you how it's going with the getting the account. How's it going with the account?
Oh, I have the account. I'm sorry.
Oh, you're ready? Okay, all right. Okay, so
Yeah, sorry, I forgot to say.
okay, all right. And everybody else either has Vivado open or has the account. Okay. All right. So let's take a look. This is going to be one of your easier labs, so enjoy it because they do get harder. And let's take a look at what you need to do for this lab. Oh, Will, if you could scan that QR code, that would be great. And tell me when you've gotten it. Okay. All right. So now, okay. So in this lab, I believe all you are doing is using Verilog to simulate a flip-flop. And you do have some pre-lab work that needs to be turned in ahead of time, so I want to make sure that y'all understand what you need to do for that and what you're going to be doing with this lab. The first thing that you're going to do is to make a module for a D flip-flop. And it's going to have the module name DFF alpha beta. Your inputs are going to be D and clock, and your output is going to be Q. And it says to use the code on page 4 of the lecture slides of Verilog Basic for sequential circuits, and use a non-blocking assignment inside the always block, and to name the module this. And this is going to be something that I believe, I thought it was in green that you had to have ready. Let's see. I could have sworn that was originally, these files are to be submitted individually as pre-lab work. Oh, for for the M's, not for the D's. Okay, but we'll see how to do it by doing this. That's interesting. Oh, you're gonna change it. Wait. Okay, so I'm not saying that you have to do this one for the pre-lab, but if you have it done for the pre-lab, it will save you a lot of time. Okay, all right. So let's take a look at the PowerPoint that you're supposed to get the code. Well, first I'm going to go to the website, the Moodle site, and go to Lab Resources. And under Lab Resources, using Vivado with the Basis board, and follow the steps for creating a new project. We're just going to go through these steps. I'm actually going to create. So this is something that y'all can do too, so that you'll have it ready to go. So from Vivado, create a new project. And I don't think that it matters really what you call it. Is this Lab 5? Lab 5 is what I'm calling it. And we need to make sure that it's RTL project. We won't specify any sources. RTL project, not specifying any sources. And then we're going to pick the right package. So we want Family Artix 7. And package CPG 236. Speed -1. And the one we want, I believe, is the middle one. 236-1. 236-1. So that's the one we want. And then next. And finish. And then we're going to be ready to put some code in here in just a minute, but I'm going to go ahead and go over to the website and get that set up to do the same thing. So now I'm going to the EDA playground right here, and what I'm going to do over here is if you look on the left under examples, it should say Verilog, System Verilog, and you want to click on that. And so let me know if you're not able to follow along for anyone who is using this. So under examples, the first example is D flip-flop. We're not actually going to use that D flip-flop. It just has all the settings that we need. So you can click on D flip-flop and it'll open it up. And then down in the bottom, you'll want to save it with a new name. My D flip-flop. And you can just delete all the code that's already in these windows because we're not going to be using it. Oh, actually, should have clicked copy up here where it says copy, you click copy first, and I am not logged in, so I need to log in. Copy, give it a new name. And save, and I'm just going to delete the code that's already in here. Okay, so now everybody should be set to start putting some code in, either in Vivado or online. So is that in fact the case that everybody is set, or does anybody need more time? Does anybody want to do some organic chemistry? Okay, all right. I'm not seeing anything in the chat. All right. Okay, so now let's take a look at that PowerPoint that he directed us to. Which is in lecture slides. And it was Verilog for combinational logic. And so you'll want to, you don't have to download it if you just want to copy it off what I'm going to have on my screen here. But if you download it, you can just copy and paste. And let's see, he said in the instructions, he said, use the code on page 4 of the lecture slides. Let's see, what page is this? I think this is the wrong PowerPoint. Let me go back. Verilog Basic for sequential circuits. I think I got the wrong PowerPoint. Yep, I did. I want the Verilog Basics for sequential circuits. So Verilog Basics for sequential circuits. And I want page 4. And I'm going to get the code for the D flip-flop, but you have to make some changes to it. So it's right here. Oh, and then oh no, it is, I can't copy it. Okay. So, but he had some instructions for how he wanted to change it. So I'm going to copy this and paste it into Vivado. So I heard the chime. So whoever came in, if you have Vivado, if you want to open it up, we're putting some stuff in here. And I'm going to make a new source. So design sources. So now I'm in Vivado, design sources, and click on the plus for adding sources. And I'm going to create a design source because this is the actual code. And then next, and then I'm going to do create file. And my file name, maybe I will call, did he say we were supposed to have a specific name? Oh, I was supposed to name the project Lab 5, so that was supposed to be the name of the project, but, so I did not name it that. DFF, I'll go ahead and call it DFF underscore RR. And finish. And I'm not going to put the inputs and outputs in here, but I could if I wanted to. I'm just going to say OK and yes. And now I have my first design source, and it's got some comments, and that's pretty much it. And I'm now going to paste in the code that I just copied, but I need to take those inputs and outputs out. And then I am also going to change, so if we look at his instructions here, we're supposed to have capital D, capital CLK, and Q. So I'm going to change clock. I usually actually just use capital CLK like that. And input CLK. So we'll have that. And then this is also, if you're doing it in the EDA playground, that's the same code that you would put in over on the right hand side for design. So I'm going to wait a minute until everybody has this code the way I have it, or if you wanted to do something else, you can do something else, but I want to hear from anybody who's here that you either have the code or you're having trouble with something, and then I'll help you from there.
I think I have it.
All right.
I have it.
Who was that?
Jared.
Okay. Raylan, okay. Okay. All right, so I think that's everybody. Okay, good. All right, that is so no, I'm not waiting on anyone. Okay. Now let's go back and look at the instructions and see what else he said. He said use a non-blocking assignment inside the always block. And so what that means is, so right now it's just saying always at the positive edge of the clock make Q equal to D. So a non-blocking assignment is it doesn't use the equal sign, it uses the little less than or equals to, and what that does is it freezes things when you go into the always block. Let's see, why is this telling me it's got errors? Let's see what the errors are. Error. Oh, because I did not change clock. This always at positive edge clock, this is supposed to be always at positive edge CLK. And I also have, for some reason, had an extra close parentheses, had an extra end module. Don't know why I had that. Oh, because I copied, yeah, there were two end modules because I copied one into there. So I had to change that. All right, so those were a couple of changes I needed to make. So what I'm going to do is that changes it to the non-blocking assignment, but I don't want to just do that. It might work for just a D flip-flop, but the D flip-flop is the simplest of all flip-flops. It all it does is Q follows D. We might need to build, you will need to build flip-flops that are more sophisticated than that. So probably the best way to do it is by having two always blocks. So we're going to have another always block that is going to figure out what it's going to change to, and then the second always block is going to be actually doing the change. So I'll have always at, and then here, this is where I want something to happen. I'm going to put whatever variables I put in here. It's like whenever one of these variables changes, I want you to do what's in this always block. So I'm going to put always at D, because anytime D changes, I want to change what the next state is going to be. And I'm going to right now put a begin and end here. We're not going to actually need it here because we're just going to have one line. But if you reuse this later, it might be helpful to have the begin and end in there. Now, rather than just having making Q equal to D, I need to do, I might have lots of things that are going on to figure out what my next state is going to be. So in this instance, my next state is just going to be D. So it's really easy here, but that's not always going to be the case. So I'm going to put in here another variable that's going to be a wire, and I'm going to call it next state, and I need to make it a reg because I'm going to change it inside an always block. And what have I done wrong? Illegal net data type. How is that possible? Let's try it just reg next state. Yeah. So is this extended to the code or actual edited part? This is extended. This is extra. So well, kind of. He said change it to a non-blocking assignment. And so you could just have added the less than sign in there, but I think this makes it a little better, and it will be helpful later. So you can do it without what we're doing right now and try it and see if it works. And we can try it actually when we get ready to actually test things. So we can try it with and without. So right now we're going to go ahead and put it in. We might take it out later. So now what I'll do is I will say in this other always block, I'm going to say, yep, that was it. Okay, so I'm going to say next state, because this is going to be what you have to do most of the time. It's just with the D flip-flop you don't actually have to, because it's just the single thing. So now I have next state is D. Okay. And I go and paste this in over here. And then what I am going to do, let me save this.
Can you explain again why we added the extra always block?
I will, yes. Let me come over here.
Okay.
Okay, so let's say I have, I want to do more than just have I could do it all in one always block. I don't have to have two always blocks, but I noticed that this was actually his recommendation to have two always blocks. So let's say I have a circuit that's like this. Oh, let me pull one up from. Oh, this is the wrong class. That's a cat. That's physics. Okay, so let's say your job was to make this flip-flop, which is something that you had to do on the homework that you turned in before. So you're going to have you're going to have like a case statement, and you might have a case statement. So you might have a case statement, and you would have the different cases for what you want to happen depending on what XY is. So like there we go. So this is not a flip-flop, this was a multiplexer, but it's the same basic idea. So I have this case statement that is telling me what, in this case, my output would be. And so I want that to be computing whether or not I'm at the positive edge of the clock. And so I have all of these things that are going on to figure out what my next state is going to be. And so I want it to be ready when the clock changes, to be ready to load the next state. And so when I am doing my first always block, so always at, and maybe it's at X, Y, and whenever any of those things change. And then maybe I have a case statement, so I'll have begin, and I'll have I might not need a begin if all I have is a single case statement. In case, and I'm forgetting the syntax here, it is, that's Greek, that's not useful. Case, it was when you put two of them together. I'm not remembering. Okay, well, I will be case, I'll just put X. And I'll have, if X, maybe X is a 2-bit variable. So case X, and I'll have 0, 1, 2, 3. And if X is 0, then maybe I want next state to be whatever, maybe it's I have it defined somewhere as A, and if X is 1, I want my next state to be B, and if X is 2, I want my next state to be C, and these are things that maybe I've defined somewhere else. And so I could have various things going on, so switches that I'm switching on the board, and these are not, the switches are not necessarily going to be switched right as the clock edge happens. So this needs to be ready to go before you get to the clock edge. And then when you get to the clock edge, that's the second always block. So always at positive edge clock, that is when you're going to have the statement that Q is going to become your next state. And so this, you know how he talks in class about the what and the when? This is the when, and this is the what. So the what is what your flip-flop does. The when is when it does it. The reason that we don't really need them for the D flip-flop is the D flip-flop, there's not a whole lot to the what. The what is Q is D. But for all the other flip-flops, there is more to it. Did I explain it all? Did that help at all?
Yes.
Okay, good. All right. Okay, so next, let me see what else was in the instructions. Well, actually, let me go to the website. This, I had done this earlier, so I think it's the same thing. Yeah, so it's the same thing that we have, just kind of different. And I had put in a test bench here. And so, and we can do this later, but I'm just going to show you how this test bench works. And so what I put in this test bench was I had my inputs had to be reg. My output was going to be a wire, and that's how you always do it. And then you have your unit under test, and so you can call it whatever you want, and your unit under test. And then in parentheses, this time I did use the kind of dot notation, which meant I didn't have to have it in the same order as I had over in the source, but I did keep it in the same order. I didn't actually initialize anything here, so I don't think this really does anything. Oh, if you are using this and it gives, I don't know why it's doing this now, if it gives you that error when you try to run it, you have to go under Tools and Simulators and uncheck the box that says Show Output File after Run. And unexpected token. No, I did need to be in. Yeah. Okay, and so what I told it, so the way a test bench works is I told it, well, let's start with the clock equal to 0, and then I made D equal to 1. And then this was just something I put in because I was trying to figure out what was going on. And then I had this little function for display that's going to show me what's going on. I could just put in rather than that, I could put in this. So this says display. I want to get the values of D and Q. I want it to show me what the values of D and Q are. I have it here in hex. Binary would work just as fine. And then I just told it to tell me that it's toggling the clock. That's just going to display on the screen. And then I change the clock to 1. And then I will display my values again and see what happens. And then I change D and I display the values again. And then I toggle the clock, so I change the clock to 0. And then I put in a little delay here because if it was going too fast, and it was going too fast for the flip-flop to register the change, so the hashtag 100 says delay 100 nanoseconds, and then change the clock to 1 again. and now it had a positive edge of the clock, and so at the positive edge of the clock it should show me that my D changed, and that is what it in fact does. Let me run it again. So if I something's not working. Let's see. Oh, here's my problem. I need to name it the same thing. DFF underscore RR. Port D not found in work. Clock not found in work. Because I have all capitals on the left and all lowercase on the right. I'm not going to go through and debug all this because that would take too much time. But if I had, what it would show at the bottom it would show that the D was changing as the clock changed. I had it working before, and then I went and changed the capitalization, and so that messed everything up. Well, I'm afraid y'all won't believe me that it works if I don't change it, so let me change it. One error. What's my error? Display. Line 30. Line 30. Display. Notice I went down here, so what I just did, it's telling me where my error is. So line 30 right here, line 30, character 26. Under line 11. CLK. Finally, okay, so look, so you can see that what the test bench is showing me. So this is what a test bench is good for. So it starts off by telling me that D is 0, Q is we don't know, that's the X. Then it toggles the clock. Actually, nothing happens here because the first toggle of the clock makes the clock equal to 1, but I think maybe nothing happened because it didn't have enough time. But then, oh no, it's okay, well, this was a failure. I had it all working this morning, and it's just still not saying that it never got the value for Q. Did I have these in the right order? Yeah. D, clock, Q. Okay, I'm not gonna, I did have it working, I promise, but I'm not gonna be able to see what the mistake is now. So I'm gonna go back and look at what it is that we need to be doing for your lab. Okay, name the module this. Okay. And then it says you need to make your constraint file. And so your constraint file, this is something that you have to have Verilog for. So to get your constraint file, you can go to the Moodle site and get the in the lab resources, the constraints file template, and you don't need much for this one. I think we only need switches for this one. Switches and LEDs. Let's see. We want map the clock input to one of the push button switches, and D to any switch, map D to any switch and output Q to any LED. Okay, so what you'll need from your constraint is you'll need the clock signal. So we'll get that, and I'm going to make a new constraint. So I'll go to constraints and plus, add or create constraints. Next, create file. I'll give it a name. And finish. So the clock signal, now in the lab, I think he gives you code for the clock signal, but I think this is exactly what it is. But let's look and see if it's the same as what he put in the lab handout. No, it's not. It's not. So you don't want that clock, you want this. You want the clock from the lab instructions. Now you are going to have to make a change. Notice that this one has the name capital CLOCK. You'll want it to have the same name as your clock, and what this is doing is it's mapping it to the push button U17. So you'll want to make those changes that I just made. So that one's for button U17. And we'll also need to get one switch and one LED. I'll just go ahead and get this top switch. And I'll get an LED. And you just have to pay attention to which ones you get. And I would call the switch D. Oh, I apparently had my clock named with a capital CLK, so this should have been a capital C. This is why it takes me forever. I am the slowest programmer in the world because I make so many mistakes. Okay, and then we would give it the name. So this one would be D. And this is going to be Q. And let's see. Do I dare? No, I can't stand it. When it finds all the typos I have, I'm not going to manage. I'm not going to handle it well. All right, let's see what else we've got. Okay, so that's that. So that actually is going to be something that you didn't have to have done before you go into lab, but now that you have it done, you can copy it and take it in with you. And then we're going to program the board, and then you're going to go in and you're going to change it to negative edge instead of positive edge, and you'll see if it works. Now, for the rest of your pre-lab, you have to write the Verilog code for a one flip-flop machine, and you have to have this ready to go. And this is why I went ahead and put the two always blocks in, because this is what you have to do for your pre-lab, is to write the code for a flip-flop like one of these. So I am not going to do one of these, but I will do one like one of these. So let us go to the toggle no change set reset. Okay, so you'll notice that when I did this last year, I did not make 2 always blocks. That's a change that I've made because it does seem like that is something that he prefers. And make sure this is not what y'all have to do. It is kind of, so let me hey, I'm SI. Okay, so this I did this with just 1 always block, but I'll change it so we'd have 2 always blocks. Because all what this would do is it does it all in one step, which it does work because I did it, but it's kind of better to separate the what part from the when part. So this is what the example is that y'all had, but let's say instead what you were supposed to do is if you have x, y, and q star 0, 0, 0, 1, 1, 0, 1, 1, and let's say that we had no change, toggle, and 0. Okay, let's say that's what we had to do. Okay, so the way this would be different would be I would have reg next state, and then my first always block would be always at x comma y, and then I would have my case statement would tell me what to do in each case. And so when I look at my x, y over here, this corresponds to 0, 1, 2, and 3. So I put my x and y together in these curly brackets, and that will treat it like a 2-bit number. So that's where the two apostrophe B 0, 0 is coming from. It would also work fine to just have 0, 1, 2, 3. That also works fine. I left it with the binary numbers because the first column corresponds to X and the second column corresponds to Y. So you can see it on your switches. And so with my example over here with no change, then this, what I had here before was Q, this would now be next state, would be Q, and next state would be Q, and next state would be not Q, because that was a toggle, and the last one, next state, would be 0. And then I always like to have a default. This time it's not necessary because I definitely have everything accounted for, but just in case, default next state, let's make it 0 as my default. And then for my second always block, I would have positive edge clock, and then I would have at the positive edge of the clock, Q will become next state. Let's see, for example, this would be as if you had a next state from the module 2 given. No.
I
I mean, as if like what you just did for your example, like the no change one with the one that you're doing the Verilog case. Is
Uh-huh.
it referencing towards the one that we have to do for the pre-lab, or is just yours
Nope.
on your
Nope.
own?
This is just I made up.
Oh, okay. So
Yep.
basically, you just renamed it the output next state, basically.
I did. So well, kind of I did. I renamed the output next state, but then I used it to make it Q in the second always block.
Oh, okay. So you basically just renamed it for the always okay, like you said.
Yeah.
Okay.
Um, trying to think if I can. Let me see if I can pull something up from what he did. Um, well, I may be getting my professors confused. Uh, this is fun for next week. Um, this one puts things in different modules. But it has the positive edge somewhere else. So it really, it really is up to you at this stage. I just know that at some point I realized that somebody, and I don't remember if it was Dr. Trahan or Professor Vady, really wanted to have the two separate always blocks. So I started doing it that way. And it may have been a different professor. So it may have been Dr. John. But either way, for this particular program, it will work without having to always blocks, I think, because it did last year, so that it should work fine. No, now I remember specifically. So for the final project, that was it. For the final project, he wanted them actually in separate modules where you did your sequential work in one module, and then you made it you did the combinational work in one module, and then you did the sequential work in another module. But this either way will work fine. So if you wanted to have just one always block, that should be okay. Um, Also notice with this one, when you get to this one, you would have to have your constraints. You'd have to add a constraint because you now have. Oh, I'm in the wrong. I thought I closed this. I don't have the new constraints on here. So you'd have to have new constraints because you have both an X and a Y. And so you would have to have, two switches for that instead of just one when you get to that part. But you will get to that part because that's part of your pre-lab. So on your pre-lab, you're going to have your constraints. You'll need to have both a switch for X and a switch for Y, and an output for Q, and also the clock.
So 2 for each, for X and Y, and for
You'll only
Q and
need
clock.
you'll only need one for the clock. So you would need, so like what I have here. So you'd need a switch for X, and you would need another switch for Y. And you would need an output for Q, it would be an LED, and you'd need the clock as he has it in the lab handout. And I think that may be it. This is going to be the shortest lab for a while. So you are supposed to, for your pre-lab, do the Verilog and constraint files, which is basically what we just did there. And then in the lab, you're going to actually implement it. And it should be pretty quick. So this should be a very short lab. So any questions?
Could you go over for this one? This was for the constraints file. This is for the pre-lab work or for the D flip flop.
This is for the pre-lab work. So this is
Okay.
this is exactly what you need for the pre-lab. I mean, exactly. You can use different switches or a different LED if you want, but it should be exactly right.
Mhm.
Will this session be recorded for late? Yeah. Oh, I'm sorry. He left and I didn't. Yes, it will be. So yeah. So the thing that would be different for the D is that you'd only have to have. You don't need to have both X and Y, and it would be named D instead of X or Y. Other than that, it would be the same. And then your code for the XY flip-flop is, I mean, it's real short. I mean, it's just that, I mean, I did the 2 always blocks, but you can do 1. But it should be pretty short. Other questions? All right, now I have a question for y'all before you go. I'm not seeing that y'all have any homework due, and y'all have a test next week. Is that right?
Yes, we have our midterm, and it's the reason why we don't have homework, I guess, because we don't have class on Thursday for fall break.
Right. Now, I am going out of town for fall break, and I have a doctor's appointment on Wednesday. So I was thinking, since y'all didn't have homework, probably I would not have a session on Wednesday, but I want to make sure that I get stuff in before y'all's. Your test is going to be the following Thursday, right?
Yes.
Do you think that the Wednesday before break, people would even want to have the session then, or they would want to wait and have it later? Do you think people would?
I'm personally fine with either one.
Okay. I'm interested in other people's opinions. Like, would y'all rather have a session on Wednesday, or, I mean, it would be the same number of sessions probably, whether I had one Wednesday or not. I'd try to get as many in as I could. I just hate to prepare for a session and then not have people come. But no thoughts?
I think I would probably rather wait until next week
Mm-hmm.
than Wednesday, but if you have one Wednesday, I can still try to go.
Okay. And then some people can't come anyway because they have a class at that time. I don't even remember what time that is, but okay. Well, I will try to figure it out, and I will make sure I do what I can to help. Now, last year, I had a couple people tell me that what I did at the review session for the midterm was very helpful. So I need to make sure I find out what I did at the midterm, because they said one of the questions I did was a lot like what they had on the exam. So I need to make sure I figure out which one that was and make sure I do it again. Anything else? Okay, well, thank you so much for coming. These SIs where I'm doing the programming is always a little more scattered, just, because there's all these places where I can make mistakes. But I hope you got something out of it anyway. And I will see y'all later.
Thank you.
You're welcome. Bye-bye.
Thank you.
Bye.